So I am dealing now with expansion of liquids. As I clearly mentioned, you require a container to heat the liquid. So this is my container. For my convenience, say till some mark A, I have filled the liquid in this container. Okay. And now I'm heating the container. The objective of heating the container is to heat the liquid inside. For this purpose, so I'm heating. So what will happen is that initially the level of the liquid will fall to some level B. And thereafter, through the process of heating, the level will rise from B to C. See, one thing is clear, B to C is a real expansion. Whereas A to C is with respect to container. Whereas A to B refers to expansion of a container. In one shot, you have a vision of three things. Have you noticed this? Everyone in the class. In one shot, you have a vision of this. Right. So a liquid will have two types of expansion. One is apparent expansion. The other is real expansion. Apparent and real. See, now accordingly, coefficients. So gamma apparent is defined as, let us assume the cross-sectional area is some S into AC by the initial volume into rise in temperature. Gamma real S into PC by initial volume into rise in temperature. Till this point, I don't think you have any observation. Yeah, one thing is clear, no? You can write BC as AC plus AP. S times BC as S times AC plus S times AB. S times BC is nearly gamma real. S times AC is gamma apparent plus gamma container. Generally, we don't express gamma for solids. We will express everything in terms of alpha. So therefore, gamma real is gamma apparent plus three alpha. That is the relationship between the three coefficients of expansion. So they don't believe straight away that a liquid will have real expansion. You measure sometimes with respect to real, you measure sometimes with respect to apparent, depending upon the situation. Whether it is a solid or a liquid, one more important point that you should take care. What is that? For example, you take a matter in the form of either solid or liquid because applicable for both. See, thermal expansion process mass remains a constant. Yes, sir. So, how is it possible? As you heat, the volume change. So, how come mass remains constant? How come mass remains constant? Yes, accordingly, the density will also change. So, since mass is volume into density, so as volume change, density will also change. Now, for example, V naught, rho naught corresponds to 0 degrees centigrade volume and density. And Vt rho T corresponds to volume at some T degrees centigrade. But issue is this, So rho T is rho naught by. Remember, when you are writing this expression, you are writing this expression for a solid, isotropic undoubtedly, but this is for a solid. If we are applying the same for a liquid, you should be careful in writing this is for liquid. This is for a liquid. For a solid, you have the condition. For a liquid, you have the condition. Any doubt till this point? Right. అర్థం నేరో కదా అని అప్పుడు వాల్యూమ్ చేంజ్ అని తీసుకుందాం ఇన్స్టెడ్ ఆఫ్ దట్ బట్ నేరో నెగ్లిజిబుల్ రైట్ సో దిస్ ఈస్ ద కండిషన్ సో డెన్సిటీ విల్ ఆల్సో చేంజ్ ఫర్ ఎ లిక్విడ్ యాజ్ వెల్ యాజ్ ఫర్ ఎ సాలిడ్ according to the relation given here. Now, not only that, see, sometimes what will happen, when you are taking the consideration, okay. Right. How to measure gamma apparent? Gamma real is not possible directly to measure, but you can measure gamma apparent. For this purpose, you will use an arrangement called specific gravity bottle experiment. So how it looks like? Is a long necked . and a round bottomed bottle. You can close this with a cork. And the cork is again made of same material. And the cork will have a bore inside like capillary tube. It's like you are closing the mouth with a capillary tube. The capillary tube will have a bore inside so that water can come outside. If required, I can inject water into it. Right. Now what I am doing is at 0 degrees centigrade, I will fill some liquid. I am writing W1 as mass of empty specific gravity bottle. When I said bottle, the bottle includes the bore, the what do you call the cork. Okay. W2 is mass of specific gravity bottle plus a liquid at 0 degrees centigrade. Right. So to show this observation, I'll simply mention. Actually, honestly speaking, opening part there is nothing. Because you close this with a capillary tube. So anything is inside all. Let V refers to volume at 0 degrees centigrade. Volume of the liquid at 0 degrees centigrade. Till this point, any doubt? Boys and girls. No. Now what I am going to do is, I am going to heat this entire arrangement. It's a water tub, beaker otherwise. And here is my specific gravity bottle. And I hanged this, holding it like this. And you have water till this point. And you are heating the water. The objective of heating the water in the beaker is to heat the liquid inside the capillary tube, because you cannot heat the capillary tube directly. Sorry, the specific gravity bottle, liquid contained in the specific gravity bottle directly. Till here, any doubt? Boys and girls, till here, any doubt? Sure? Everyone in the class? Why is that? Why is that? Why is that? I just demonstrate how to heat that liquid directly. If I don't heat it in this way, you are expecting me to post that entire container over some burner. In that case, uneven heating takes place. In this case, even heating takes place. That is the reason. You should ask me a question like that. His intention is, why not directly you heat specific gravity bottle? Because I want to heat this uniformly. Right? Now, what happens? Now you are heating it from 0 degrees centigrade to some T degrees centigrade. Can you please tell me what is happening in the course? Okay, liquid will expand. So what? liquid. So we will avoid that overflowing onto the surrounding tank. We should rather say the word oozing. The excess, whatever it is, it oozes out through the capillary tube. And time to time, I will clean and I will remove the additional excess which was coming out through the capillary tube. Now tell me why the excess is coming out, because expansion, there is no space. So at a T degree centigrade, you have the entire specific gravity bottle filled with the liquid, but some portion came out. Now then I will remove that and I will allow it to cool again till 0 degrees centigrade. Now then I will measure, only then I will measure the temperature, mass. So W3 represents mass of specific gravity bottle plus remaining liquid at 0 degrees centigrade. Now please try to see, you will see two different pictures here. You will see two things here. The liquid inside the capillary tube at T degrees centigrade, this is what you are seeing. At 0 degrees centigrade, this is what you are seeing. Right? Can you please help me in understanding what is this volume corresponding to? Actually, apparent expansion with respect to the container. So what is gamma apparent? Expansion with respect to container, original volume into rise of temperature. Now let us assume that this volume is V2 and this volume is V1. Can someone please help me in writing of V1 properly? V1. How to write V1? Boys, how to write V1? Wrong. Wrong. W3 minus W1 by rho naught, density of the liquid at 0 degrees centigrade. What is V2? V2, by the way, W2 minus W1 by rho T. Okay? Right? Now, what is gamma apparent formula? Gamma apparent formula is V2 minus V1 by V1 times delta T. V2 minus V1 is nothing but, here I have done a mistake. Hold on. Same. It is rho naught because we are measuring both at 0 degrees centigrade only. At 0 degrees centigrade, the entire liquid was occupying the container. Initially, whatever the liquid you had, that liquid is occupying what? Complete volume of the container. V2 is at no. That is the volume occupied by the liquid. No, so remaining liquid is occupying that much volume in the container at T2 degrees centigrade. Right. Now, what is that I require is apply this relation. W3 and W2 minus W1 by rho naught minus W3 minus W1 by rho naught. W3 minus W1 by rho naught into delta T. This is nothing but W2 minus W3 by W3 minus W1 delta T. Rho naught cancel. What is the numerator part? Can you please explain? Mass of expelled liquid. What is W3 minus W1? Mass of remaining liquid into rise in temperature. Earlier, we used to have a discussion in waves chapter. What we are measuring in an experiment is important. In the entire process of the experiment, you will take only 4 measurements. Can you tell me what are they? You will measure W1, you will measure W2, you will measure W3 using common balance and thermometer tick. Only these measurements. With these measurements only, I have answered your question, gamma apparent. I have answered your question only on the basis of the measurements done by you. Yes or no? Clear or not? So therefore, finally, we have gamma apparent. So therefore, gamma real is gamma apparent plus 3 alpha. Using this relation, you will determine the gamma real of a liquid. But basically, experimentally, what you are finding is gamma apparent only. You are measuring gamma apparent and thereby you are finding gamma real. Right. Next part which I need to discuss is one observation which I need to discuss is yes. Ask me. Why you are confused? I am still. This is the volume at T degrees centigrade occupying full volume of the container. And that is the same liquid which is occupying almost full, but some portion is left at 0 degrees centigrade. I didn't answer in terms of W's. I have answered in terms of volumes. నీకు ఎందుకురా డబ్ల్యూస్ లో చేస్తే నువ్వు మెజర్ ఎలా చేస్తావు చెప్పు ఓకే ఫర్గెట్ అబౌట్ దిస్ హౌ యూ విల్ మెజర్ వాల్యూమ్ ఆఫ్ ద కంటైనర్ అట్ దట్ పాయింట్ రాదు వాట్ ఈస్ ద వాల్యూమ్ ఆఫ్ ద కంటైనర్ అంటే యూ ఫిల్ లిక్విడ్ how much volume of the liquid is fitted in that, that is considered to be the volume of the liquid or volume of the container. That's what I would like. Got the point? Right. See, experimentally, what can be measured is what we need to focus. It's not that what we know. Right. Now, the next part that I need to discuss here, you have a container. And in this container, you filled some liquid. Notice there is air gap, or I can say, what you will call that as air column. Air column, otherwise. I am heating this container. I want the volume of the air column to be constant always. Can you give me any condition that reflects this? Question is, I am heating this container. While I am heating the container, I will be heating both container and the liquid in it. In the process of heating, can you please tell me, to maintain that volume constant, what is the condition? Gamma real is equal to what happens in that process? Yes. Tell me what is the condition for air column volume to remain constant. What is the condition? Gamma real is real. Gamma apparent will be 0 in this case. So, with respect to container, always the mark at the same mark the liquid will occupy. And the column, see, good question. For example, this is say 1 liter, 0, 1 liter, 750 ml. Now tell me, always the free surface of the liquid is at 750 ml mark. So with respect to container, there is no expansion.
But you didn't ask that, right? So you asked, let's set the volume, the actual volume remains constant.
Which one?
Actual volume of the air column should be constant. That's
Yeah, volume with respect to container is good. How you will measure otherwise? The air column volume with respect to container must remain constant. And the condition for that is this one. Next. Let me just see. I just introduce, certain there. What it will check. Okay. Let the steel rail 30-meter long is firmly attached together. Right. Initial length be both the sides కాబట్టి let it be length be 2s. Any doubt on this? Final length let the final length be 2 times S plus delta S. Now what is happening over here is this is the buckling point. Set y height. Earlier 2s. Because there is buckle, it took the shape like this. This is S plus delta S. This is S plus delta S. So honestly, y square is S plus delta S square minus S square. Y is under root S square plus delta S square 2S delta S minus S square. So finally, see, what is delta S, by the way? Right. S into alpha into delta T. S square alpha square delta T square plus 2 into S square alpha delta T. So the only thing that you can do is you can take S common out. That's all. Rest everything is inside, and that will become alpha square delta T square plus 2 times alpha 2 times that's it. See, honestly speaking, more or less, this is very small when compared to it. So this is yes, nearly. అక్కడే చేసేసేయచ్చు అదర్వైజ్ y square is when this is small, okay. Any doubts? Nothing. Leave it here. What to understand? Ask me what is your doubt. The 79 pages are there. Hardly discussed the 2 questions. Break, bend. This is bending, and it goes up like this. Buckling at the middle point is given in the question.
What is the buckling?
Bending. Technically break.
Breaking.
Almost break. Next. Actually, this is supposed to be a formula, but I am dealing it like a numerical. So what you have in this question is copper plate and a tungsten plate. This is how you have. Remember, this is copper, and this one is a tungsten. Remember, thickness is T each. Delta each. Remember, this is at 0 degrees centigrade. So, one thing that you don't know is alpha copper is greater than alpha tungsten. So, what happens? That's how it breaks. Let this makes an angle phi. Already I told you this last class. What is the principle behind this? This is also called as right bimetallic strip. And we use bimetallic strip in which? As a thermostat. Good. Right. So R. Now try to please identify that in this case, length of the copper plate is different and length of the tungsten plate is different. So nearly we will consider that the length of the copper plate is the utmost outer part of the arc. Honestly. And what is that? R plus delta by 2. Because you said the thickness is delta. అవునండి అంటే మనం మిడిల్ లేయర్ వరకే కదా తీసుకోవాల్సింది ఓన్లీ మిడిల్ లేయర్ మిడిల్ లేయర్ ఆఫ్ ద కాపర్ see what happens I will explain the outmost layer will expand more than the usual expansion. The innermost layer will expand less when compared to the actual expansion. The middlemost layer is close to the actual expansion in this process. I repeat, this is not the correct expansion. In fact, this is also not the correct expansion. Close to correct expansion is hello. అమ్మ నేను విన్నానమ్మా అవని చెప్పింది నీకు కొత్త విషయాలు ఒక్కటి బూతులు కూడా R plus delta by 2. R plus delta by 2 times 5. Can you please help me? Same with tungsten. Don't take this layer also. This is a compromised layer. I need to do one question on the basis of this. I'm going very slow. Right. చాలా స్లోగా వెళ్తారు. ఇంకా 3 రాడ్స్ ఉన్నది ఒకటి హెచ్సివర్మ క్వశ్చన్ అంతే. బట్ ఐ నీడ్ టు డిస్కస్. Where am I? Okay, right. What do you want? Otherwise, this is called L naught times T. Otherwise, this is called right. Any doubt till this point, boys and girls? Pakka? Sure. I am asking again, do you have any doubts? So R plus delta by 2 by R minus delta by 2 is 1 plus T by 1 plus T. Now you need to solve this. By solving which you will get R as a function of delta. Otherwise, why should I do all these things? I got frustrated. Why should I do all these things? What if I do the difference? I won't get R. That's the problem. I will get L naught. So no, 1 minute. What if I'll take this as equation 1? I'll do small magic. Cheating. Delta phi is L naught times. Honestly, can you please help me? What is the perfect replacement for L naught? గట్టిగా చెప్పవా? దానికి అర్థం అయిపోయింది. ఐఎమ్ చీటింగ్. R into 5 nearly. So 5 cancel. So the radius of curvature is delta by alpha c minus alpha t times t. It's a perfect situation. Any doubts? If you are not interested, welcome. Divide 1 by 2. Finally, you'll get the same. Yeah, you need to do some small adjustment. Why I want finally this format of it. Common portion, compromised portion, right? Next. Yeah, this you can manage. What is the formula for maintaining what you call L1 alpha 1 is equal to L2 alpha 2? I'm just leaving some questions. 1.11. This also you know. A clock with a brass pendulum shaft keeps correct time at a certain temperature. How close must the temperature be controlled if the clock is not to gain or lose more than 1 second a day? How many per day? We know half alpha delta theta 86,400. ఏంట్రాశారు ఇది? లాస్ ఆర్ గెయిన్ ఇన్ టైం. అలా చూడకండి రా, భయం వేస్తుంది నాకు. లాస్ ఆర్ గెయిన్ ఇన్ టైం పర్ డే. ఓకే, దిస్ ఈజ్ లెస్ దాన్ ఆర్ ఈక్వల్ టు 1. దట్స్ వాట్ యు హావ్ గివెన్. ఇప్పుడు మీకు ఏం కావాలి? డెల్టా తీటా లెస్ దాన్ ఆర్ ఈక్వల్ టు 2 by alpha times 86,400. Delta theta less than or equal to 2 into 10 power minus 5 into 86,400. Someone kindly please use calculator and give me the correct data. మా గాలిలో చూడకండి, క్యాలిక్యులేటర్లోనే చేయండి. Someone fast time ticking. 1.16 nearly. Hmm.
The actual change in time period.
Into 86,400 చేశాక that corresponds to per day. Dayలో 86,400 seconds. So the difference in time, suppose at 10 degrees centigrade, it shows correct temperature. So to maintain the same correct time, if temperature falls, 1.16. Temperature rises, 1.16. So the bandwidth allowed for me is 2.3, nearly 2.3 degrees. With respect to correct temperature, 1.16 height. With respect to correct temperature, 1.16 low. So the bandwidth allowed is 2.3. Right. Will an increase of temperature cause the clock to gain or lose? What happens if the temperature is raised? That is okay. Loss or gain? Clock runs fast or slow? Gains time. Yes. If no, 1 minute, don't confuse me. If the temperature rises, normal electronic clock for 10 hours, whatever the time, exact 10 hours, this clock will measure something less than 10. So slow, it goes slow. So loss you should say. Loss. ఒరే టెంపరేచర్ పెరిగితే టైం పీరియడ్ పెరిగితే నెంబర్స్ ఆఫ్ సైకిల్స్ తగ్గుతుంది కాబట్టి వాట్ హ్యాపెన్స్? క్లాక్ రన్స్ స్లో. స్లోనే అంటాం. స్లోనే గెయిన్ ఎందుకు? రన్స్ స్లో. It's not time period here. An increase in temperature makes the pendulum go slow. Slow means it loses time.
If it goes slow, means it will measure extra time.
Are you're planning to go for an examination with respect to a proper clock. You are supposed to report sharply at 11 o'clock. Okay. So you did not believe your hand watch and you believed this clock and you went to write the examination. What happens during summer season? It goes slow, which means you assume that it is not 11, still it is a 10:55. You will wait outside and exactly at 11 in your clock, you will go. What happens? You will be kicked out of the examination hall. Why?
Because I believe
Not because of the belief is what. The clock runs slow. So if the clock runs slow, now please remember I'm making it hardcore to remember this. Slow, loss. Fast, gain. I repeat, slow. Watch running slow means loss. For example, take the other case. Instead of 11 o'clock, they asked you to report early morning 6. Under climatic conditions, your clock will run fast. Instead of supposed to report at 6, you will report at 5:55 only, because you don't know that your watch shows it is 6 at that time. Earlier, not now, earlier, when we don't have these digital watches and all that, our standard watch is HMT watch. HMT watch, which runs with key. At that time, our parents used to listen to radio. So they will tell that now the time is so and so. At that time, we will set clocks to 8. Say, for example, my father used to do that at 8 o'clock. Why? Because the key, whatever that they are giving, it stands for only 1 day. Again, the other day when the clock ticks 8, almost same time it will show, hardly few seconds. But they will set to 8 again and they will give key. Okay, right. Next question. Make it fast. Pendulum clock loses 12 seconds a day if the temperature is 40 and goes fast by 4 seconds a day if the temperature is 20. Now what is happening? The correct temperature is somewhere between 20 to 40. Right. Let theta C be the correct temperature. Or theta C is the temperature where the clock is calibrated. Find the temperature at which the clock shows correct time and coefficient of linear expansion. Right, no issues. Okay, right. Half into alpha into half correct 40 minus theta C into 86,400 is 12. Any doubts? Any doubts? Half into alpha into theta C minus 20 into 86,400 is 4. Any doubts? Any doubts? हो गया ना question. Go for ratio. By going for the ratio, so you will get the correct answer 25 degrees centigrade. Theta C is 25 degrees centigrade. Substitute in any one of them, you will get alpha. So by substituting theta C is equal to 25 degrees in equation 1, we will get alpha. Right. That's all. I'm not worried about much in this. Right. Next question. Fast. Pinch heating is required. Brass wire of length so and so held taut at 27 degrees centigrade with little tension between the two rigid supports. If the wire is cool, don't kindly please ask me why not to heat. Heat చేస్తే వస్తుంది ఎక్కడ? Nothing. It will become loose and slack. So you want tension to form here, you should cool it. That is the reason why, see, in winter, some areas, earlier they used to have telephone wires. Usually they will intentionally hang it loose. Otherwise, during winter season, what will happen is when they were taut, they will stretch the poles towards or they will snap. One thing is possible because of the tension due to contraction. I think now you got, I don't want to teach anything in this. Trust, Jabra. ఏది కింద పడిపోతుంది? మరి ఏ క్వశ్చన్ రాను అడిగేది? So see, they were fixed to the two walls. Some tension is maintained. Not loose, some tension. 0.01 Newton is maintained, for example. Right. So therefore, stress is Y alpha delta T. Just directly substitute in this relation. You will get the proper answer. Next question. The rod of length 2 meter at a temperature, okay, find the free expansion of the rod. If the temperature is increased to 50 degrees, then finally stress produced when the rod is fully prevented to expand, permitted to expand by 0.4. Good question. What is the expression for free expansion? Free expansion means L naught alpha delta T. That is the free expansion condition. Are yes or no, yaar? Yes or no? Right. So just to substitute, you will get the answer as 0.9 millimeter. Right. I'm just giving you the answer. But time is the criteria. Fully prevented to expand, stress will form. Are they asking stress or tension? Y alpha delta T. Y alpha delta T. So Y they have given as 2 into 10 power 11, alpha given, and temperature difference 50, right? Temperature difference 30, right? So 2 into 10 to the power of 11, alpha is 15 into 10 power minus 6, difference of temperature is 30, 39 into 10 to the power of 6, 12 minus 6 kada? 7 Newton per meter square. Pretty high. Permitted to expand by 0.4 mm. Are 0.9 mm, 0.9 mm is a free, allowing only 0.4 mm. Then for the 0.5 mm, there is a strain part. Now here, strain part is 0.9 minus 0.4 mm. 0.4 mm expansion is allowed. Okay, then what is the strain expression? Point by 2. Original length is 2. How much is this? 2.5 into 10 to the power of minus 4. Remember, this is strain. So stress, Young's modulus times strain. Ten to the power of 7. Good question. Allows you to think totally into. Yes. Actual correct question started now. Make it fast. Two rods of different metals having the same area of cross section A are placed between the two massive walls as shown. Here, I'll honestly give you 5 minutes of time. On phone, it won't run fast. What have you understood here? Now, what is actually happening here otherwise? See here, what is happening? Two rods, different materials. Right, okay. So now what exactly happening over here? Let us try to analyze. Actually, let us say, temperature increased by some T degrees centigrade. In the absence of the other rod, See, I am assuming this portion which I am representing corresponds to y1 alpha 1 and the other side corresponds to y2 alpha 2. Okay, remember this length is L1 and this length is L2. In the process of heating, boys, this end can't move leftwards. This end can't move rightwards. The only possibility is the junction, the displacement of the junction. So I am assuming that the junction displaced, say by some amount x. That is the picture. In the absence of the other rod, what is the free expansion? It was supposed to be y1 alpha 1 delta t, say for example. There, that is a free expansion. No, oh, sorry. Thank you. L1 alpha 1 delta t, L1 plus L1 alpha delta t is supposed to be the final length. But it is L1 plus x now. So there is some stress. So what is the strain? Strain is simply by the original length, almost L1. This is the major step that I am going with. Any doubts? Boys, I am telling you again, this is the major step I am going with. This is strain results stress. So what is stress? The stress part is y into strain, y1 strain. This is y1 by L1 times L1 alpha 1 delta t minus x. Boys again. Are we clear? Similarly, there, what happens? It was supposed to be L2 plus L2 alpha 2 delta t. What is happening now? L2 minus x. L2 minus x. What is the strain now? Tell me, what is the strain now? L2 alpha 2 delta t minus minus of minus h plus x by L2. So stress is y2 by L2 times L2 alpha 2 delta t plus x. There is something which is common for both. What is that? Stress is common for both because same cross-sectional area. I am repeating again. Stress is calm. Sahasrakshi, you are not listening. Are you listening? If I erase entire thing now and ask you to write, are you ready? Sure? And then come and do. Sure? Come and do. You want that? Why? Why you are not listening? I didn't get you. Can you please speak louder? On the record.